Hello everyone, Shravan Manthri here. Welcome to our channel CSE GURUS. So now we'll go for the next question in algorithms. So click on implementation. All the warm-up questions are done, and here we have done with this, and we'll go for the third one, number line jumps. You can check for the link in the description given below. So we'll see this question and then we'll try to get the output in C, Java and Python. So reading the problem statement, you are choreographing a circus show with various animals. For one act, you are given 2 kangaroos on a number line. Right to jump in the positive direction, toward positive only. The first one starts at x1 and moves at a rate of v1. Second one starts at x2 and moves at rate of v2. So let us see with an example. A very good example we'll see here. This is what a very good example it is given. It starts at a point 0. Let us take like this, k1 and k2, 2 are there. So let us take it starts from like this. It's a point 0, maybe 1, 2, 3, 4, 5. So these are the points it has to jump. Anyway, first one starts at 0. It will jump how many? In a one instance it will jump to 3. Second one starts at 4 and it will jump to 2 every time. This is k1, k2. Now it is asking when they are meeting. Of course, if they meet at any instance, yes, you have to print yes. If they never meet, yeah, you have to print no. So that's what. Now if I consider this one, when they meet, will they meet? Yes, of course. So what is the position will they meet means? After first jump, the first kangaroo at 3, second kangaroo at 6. After second jump, so it is jumping every time 3, right? So 3 plus 3, 6 here. Here second kangaroo, it jumps every time 2. 6 plus 2, 8. Are they meeting at same point? No. Next one more jump. So 6 plus 3, here 8 plus 2, which is 9 here, here 10. Now next jump, 9 plus 3, 12. Here 10 plus 2, here also 12. Yes, we got the same value. That's why for the 1, 2, 3, right? After 3 jumps, of course the first jump we missed it, right? So that means 1, 2, 3 and 4. After 4 jumps, the first kangaroo at the point 12, second also at point 12. Are they meeting? Yes. Now if they are never meet, of course that also condition we'll see. Now how to get the answer for this? What is the logic that we have to use? So if you consider these are, this is x1, v1, x2 and v2. How to get this answer? So before starting the answer, we'll try to have a formula here. So it's something like x1 starts at x1, first kangaroo, plus let us suppose some number of jumps, k number of jumps, it is into v1, right? What are k number of jumps? So which is equals to x2 plus k into v2, which must satisfy. Then only I can say the answer is yes, because here also you can see in this example, if I try to apply this formula, x1 0 and how many jumps? After 4 jumps, right? They are meeting 4 into v1. What is v1? 3, which is equals to x2. What is x2? Starts at 4. How many jumps? 4 jumps in v2 2. So can you see what is this value? 12. Here also 12. So now you can see that means if this formula on the left side is equals to right side, then somewhere for some k value, for same k positive number, where k is a positive number always, for some k value, if this is true at any instance, then I can say somewhere they meet. If never it is returned true, never it returns true, which means the answer is no. So that's what one thing we have to make it. And also I'll explain the special case also. Before going to the special case, we'll try to solve this equation. So what is the equation here? It is given x1 plus k into v1, which is equals to x2 plus k into v2. So just I'll write what is x1 minus x2, which is equals to this x2 is coming here. So k v2 minus k v1. K v2 minus k v1. If I take k as a common here, it's v2 minus v1. Now conclusively, what is the statement I can release here is, I'll try to write it here itself. The statement I want to release here is x1 minus x2 anyway here, which is k equals to x1 minus x2 divided by v2 minus v1. So if it is divided, which means you are getting some positive value k, which means if I divide a numerator with denominator, definitely you will get the remainder as 0. So for those who didn't understand, I'm just explaining. If the top value is something like 20, in the bottom it is something like 5. 20 by 5, something value you are getting, which is 4. Which means if I get the remainder 20 percentile 5, what is the remainder? Definitely 0, right? Remainder I'm asking. Now if I say 20 by 3, what is 20 by 3? Is the remainder is 0? No. That's why is it divisible? No. Will you get a positive integer k? No. You will get a floating point value. But if you get a constant when integer k, then I can say it is divisible. So that's what I'll write it. So the condition here, what is the conclusive condition here I want to write is, so the x1 minus x2, if the remainder I am taking v2 minus v1, which is double equals 0, then I can say yes. Is it always? No. That is also, I'll try to write it. So if you get the formula, if you get the analysis like this, the answer will become very easy. So you can see here I want to write it. Yeah, kangaroo, you have taken here x1 v1 x2 v2. So what is the condition we want to write is, if the condition here is you have to take x1 minus x2 percentile v2, it's not v1, v2 minus v1. Okay, if it is double equals to 0, I have to return immediately. Yes, anyway you have to return a string, that's why return all uppercase. Yes. So this is what one solution. If not, else you can make it, right? So here I'll write it. Else if this is not true, I have to return no, right? Now there is one more special condition where they never meet. What is the condition where they never meet? For example, there is given an example also here. Sample input, you can see. Yeah, here it is given. The answer is no. Why? 0, 2. So first kangaroo starts at 0 and plus 2. But in that case, what is the next kangaroo? It goes to 8. 2 and 8. They are not meeting. After second jump, 2 plus 2, 4. Here 8 plus 3, 11. Next 4 plus 2, 6. 11 plus 3, 4. You can see never they meet because the first kangaroo is always on the backward, right? You can see always it is a backward. So how can you say that even the same case is applied for if the second kangaroo is always backward? How can you get that logic? That means first I'll check, is that x1 less than x2, which means x1 less than x2, which means second kangaroo is always forward, at least one point it is forward. In that case, what about v1? v1, if it is less than or equals to v2, even if it is equals also, in this case you can see never they meet, right? Because x2 will be always forward because v2 is always greater or equal, right? So that's why never they meet. Reverse the condition. If x2 less than x1 and at the same time v2 less than or equals v1, in that case the first kangaroo is always forward, you can see is always forward. So then also they cannot meet. So I'll write this special case. So I'm writing this special case first. So first is if the condition is x1 less than x2 and v1 less than or equals to v2. Okay, this is the first one, or the second one, x2 less than x1 and v2 less than or equals to v1. You have to return like this, you have to make it. Anyway, you are writing this part is of course braces are optional here, only one statement inside else. So if, of course I have to write here else if, because if that is the not true, then only I have to check the next one. So like this I have written, if this is a special case, no answer, and else if this is yes, if this is true, and here else no. So let us see this answer. Is it correct or not? Of course we missed the semicolon. Here also semicolon. No. So this is absolutely fine because The error which we are getting is regarding the semicolon. This is absolutely fine. Anyway, if you have and or operators, always and is the first priority. So that's why it will take this one first, x1 less than x2, v1 less than v2. Then it will take x2 less than x1, this one, finally or. So this is absolutely fine. Anyway, submit the code. Will all 11 test cases passed? Absolutely. Yeah. No, it's more than that. Totally 29 test cases which are all got passed. So this is a code in C language. Now we'll try to write in Java also the same. So I'll try to make it in Java. Where here same constraints are taken. The parameters, input parameters. If I'll try to write it. First one, the logic. So x1 less than, this is a special case which I explained already why I'm writing this one, x1 less than x2 and v1 less than or equals to v2. Okay, then or x2 less than x1 and v2 less than or equals to v1. Then you have to return no, right? Of course, else if the thing is x1 minus x2 percentile v2 minus, not v1, v2 minus v1 is double equals to 0, then return yes, right? Else return no. So I have to write, I have to give semicolon here. So here also semicolon. So that's it, and let us see any errors. Absolutely fine. Submit the code. Yeah, here also all the test cases passed. So this is the code. So we'll try to go for Python too. Python code. So here I am writing the condition. First one, if x1 less than x2, which is and you have to write, and v1 is less than or equals to v2, then or x2 less than x1 and v2 less than or equals to v1, then return, you have to return no, right? Of course, single quotes are also absolutely fine. Next, second one, else if, which is elif you have to write in Python. Elif x1 minus x2 percentile v2 minus v1, which double equals to 0, which double equals to 0, you have to make it what is it, return yes, right? Even if you give double quotes also absolutely fine, not a problem. Finally else return no. So once again I'm telling, like, when you go for Python, please check the indentation properly once you execute. So let us see for any errors. Absolutely fine. Submit the code. Yeah, all the test cases passed. So like this, easily you have to get the answer. The thing is here, how to get this logic is very most important. If you get like this, why I have written this line, the answer is very easy. Otherwise it will become very complex to get the answer. It will take much time to get this one, right? So that's what about this question. So we'll see in the next question, breaking the records, in the next video lecture. Thank you.